Hello and welcome back to another episode of Math with Son. Today we're going to be talking about the difference between acceleration and velocity and how that can actually relate to some things that would be very, very important. So for starters, we need to know what is velocity. Now velocity is speed and direction. So let's take this pen that I have that's going to be traveling across the page. It's moving relatively slow and I'm trying to keep it at a constant velocity. I'm trying to keep it to where it's going at the same speed each and every time. Now, that would be the velocity. How fast it is traveling across the screen would be the velocity. The acceleration is different. It's very, very different. So acceleration is when you start out maybe a little bit slower, but then you increase the speed. So if you are accelerating, you might be going slow and then increase the speed to faster. And that moment where you increase your velocity is when it's accelerating. It's the change, quite literally, we're about to write it down. It is the change in velocity. So it is when you are increasing your speed, how quickly you're increasing your speed in a vehicle. If you're pushing down the accelerator, you're increasing the speed of the vehicle and you are accelerating. And then once you reach speed, then you maintain a constant velocity, then you're no longer accelerating. For instance, if you were traveling and you go from 0 to 40 miles per hour, during that period of time, you were accelerating, you were increasing in velocity. But once you reach 40 miles per hour, maybe that's the speed limit, you stop accelerating, you maintain velocity, you are no longer accelerating. That doesn't mean you're not moving, it just means you're no longer going faster than you were a second ago. You're going the same speed. Okay, so acceleration, the actual formula is the change in velocity over the change in time. So it is the average velocity over the average change in velocity over the average change in time. And you can get it by taking your final velocity minus your initial velocity and dividing by the change in time, or delta time. Okay? Now, if a velocity and acceleration are going in the same direction, so that means that you're increasing your velocity and you had a positive velocity to begin with, then that means that your object would be speeding up. Whereas if your velocity and acceleration are in opposite directions, perhaps for the basics examples, the ones that we're going to be using in general, let's say your velocity is going up, but your acceleration is going down like gravity. If you throw an object in the air, you are going to have an initial speed on that ball or whatever you threw. It's going to be going up at a certain rate in meters per second, but gravity will be pulling it down and accelerating it downward. And that would indicate that this object would be slowing down, because I don't know if you know about it or not, but the last time you threw something up, it had to slow down and then come back down to the ground. Okay? So let's go through some examples. For each example, we're going to determine the direction of the acceleration of the car. So a car travels east and it is speeding up. So east is considered a positive velocity direction. Positive velocity, I'm just going to put a plus v there. And it is speeding up. Well, if it is speeding up, that would mean that the acceleration and the direction would be having to go in the same direction. That means the acceleration would be also going to the right. So acceleration to the right, you can write it in vector format with an A with the arrow above it, that vector quantity arrow, which is known as a ray. The car travels east and is slowing down. Well, the car is traveling east. That would be a positive velocity in the right direction. But if it's slowing down, that means the acceleration is forcing it to come to a halt. That means that you are decelerating, and that means that your acceleration is going in the negative direction. The car travels east at a constant velocity. Well, if it's going to be at a constant velocity, are you increasing in speed? If you're not increasing in speed, you're not accelerating. If you're not accelerating, there's no acceleration. The acceleration is 0. So anytime you see the word constant velocity, you can pretty much assume that there is no acceleration. No acceleration. The car travels west and is slowing down. So the car is traveling west, okay? So that would mean the V is going this way, and it is slowing down. Well, if it's slowing down, the acceleration is also going that way, and it would be considered a negative acceleration, and that would indicate that the object is, well, it's kind of messed up. Okay, so traveling west and it's slowing down. Well, if the object is slowing down, that would mean that the acceleration would have to be in the opposite direction. Just because it's slowing down doesn't mean that we are decelerating. That means that we are going in opposite directions. Well, if it's going in opposite direction, if the velocity is going to the left, that means that we would need to be somehow accelerating to the right in some way. Perhaps you were traveling to the west, but then the wind started really pushing you all of a sudden and accelerating you in the other direction. And that can cause a car to slow down just a little bit. I don't know if you've been riding on a bike ever and rode into a wind gust. You kind of feel like you had to work harder or you slow down a little bit. The car is traveling west and it is speeding up. So the car is traveling west. That would mean that the V is going to the left and it is speeding up. Well, that would mean that your acceleration would also have to go to the left for you to be speeding up. So you got pushed from behind with your car with that gust of wind, and the acceleration would be going to the left, okay? So I hope that clears up a little bit with acceleration. It is very important that you understand the difference between acceleration and velocity. Velocity represents kind of your speed, but it also has your direction. Acceleration indicates how quickly your velocity is changing. Okay, so again, it goes back to that idea when if you're in a car and originally in that car you're at a speed of 0, your velocity is 0. But if magically your velocity increases and you go to like 20 meters per second, which is pretty fast, then in order for that to have occurred in some way, shape, or form, you had to accelerate slowly if that took over the course of a few seconds. Now, a lot of times you would consider an initial jolt or initial force, which is not truly kinematics. That initial acceleration normally doesn't matter. So for instance, if I took a ball and I hit it really hard, okay, that initial velocity, VI, could be 20 meters per second. If it stays at 20 meters per second, like if 4 seconds later, I'm still at 20 meters per second, then no acceleration has occurred. We had that initial jolt that took it from 0 to 20 meters per second in the matter of a millisecond. We don't really count that as accelerating. We count that as just the initial velocity because of that initial force. With a slow transition of speed, if you started with 0 meters per second and then it took you 5 seconds to get to 20 meters per second, well, then that would mean that you have accelerated over that course of time. Okay, so that would actually have an acceleration because you changed your speed. Here, initial speed, 20 meters per second. 4 seconds later, 20 meters per second. No change in speed, no acceleration. All right, that's going to do it for this one. Until next time, I would stay positive, and the next one is a big one because we're going to be talking about the main kinematic equations that tend to give everybody the worst headache known to man. I'll see y'all in the next one. Bye.